Question is, a particle is projected under gravity with velocity v in a direction making an angle theta with respect to inclined plane having a gradient alpha, the point of projection being on the plane. Show that if the motion in the vertical plane and the particle strikes the plane at an angle alpha to be horizontal, then theta is given by the equation 1 plus 3 tan square alpha multiplied by tan of theta is equal to 2 tan alpha. So this is the first part. And in the second part, also show that the velocity with which the particle strikes the plane is given by v multiplied by 1 plus 8 sine square alpha square root. It means square root of this part, 1 minus 8 sine square alpha. In this case, first we are going to draw the basic how the projectile. So this is inclined plane and the angle is given as alpha. A projectile is projected from the point, let us suppose this point is A, and it strikes this inclined plane such that it makes an angle. This is the velocity vector in this direction, then this angle is alpha, this angle will be also alpha, this is a horizontal line, and let us suppose this point is B. This is our x-axis and this is our y-axis, and it is projected by a velocity v at an angle of theta degree, and this velocity is given as v. So let us find out the various x component as well as y component of all the relative things. So the x component, initial velocity x component will be given as v cos of theta, that is, this will be u of x, this will be u of x and this will be u of y, and u of y will be equal to v sine of theta, and the g will be acting vertically downward, so it can be also divided into two components. This angle will be alpha, so this component will be g cos alpha and this component will be g sine alpha. So we can say that in x direction it will be minus g sine alpha, and in y direction it will be minus g cos alpha. So we already said that at point B it strikes with the velocity v, small v rather, this is capital V, that is initial, and this will be small v, and which makes an angle of alpha with the horizontal. So it means at B the particle makes angle of alpha with the horizontal, and it strikes with a velocity v, small v. So we can see that this implies that velocity v will make angle of 2 alpha with the inclined plane, angle of 2 alpha with inclined plane. So we can divide this final velocity v into x component as well as y component. So its x component, let's denote by Vx, will be equal to V cos 2 alpha, and y component will be given as minus V sin 2 alpha. So in the first part, let us consider the motion in x direction. Motion in x direction. We are going to find out what will be the final velocity in x direction at point B. So we can write this equation as final velocity at Vx in x direction is equal to ux plus ax multiplied by t, where this t is time of flight from point A to point B. We substitute value of Vx is given by V cos 2 alpha. We substitute the value of ux, that is V cos of theta. Ax is minus g sin alpha, g sin alpha into t. Let us call this equation number 1. Similarly, in the vertical direction, motion in y direction, we can write Vy is equal to uy plus ay into time t. Vy is minus V sin 2 alpha is equal to uy is V sin theta minus, and ay is g cos alpha minus g cos alpha into t. Let's call equation 2. Okay, when the particle travel from point A to point B, the vertical distance is equal to 0. So we can say that from point A to B, vertical distance is equal to 0. So if we represent vertical distance by s, so we can say sy is equal to 0. So we are going to use the formula v square in y minus u square in y is equal to 2a in y and sy. V square minus u square is equal to 2as. So s of y is 0. So this will be equal to 0. And we know vy is given as, or let us first solve it. So we get vy square is equal to uy square. We substitute the value of vy square. Vy square is minus v sin 2 alpha. Its square is equal to uy is v sin theta whole square. So from this we can write it as v square sin square is equal to v sin theta. Let us call this as equation number 3. So now we are going to use equation 2 and substitute the value from equation 3. We already know equation 2. Equation 2 is given as minus v sin 2 alpha is equal to v sin theta minus g cos alpha multiplied by t. So we are going to put value of v sin theta from equation number 3. So v sin theta is nothing but v sine 2 alpha. This will be cos alpha into t, and this will be minus v sine 2 alpha. So this will be coming as minus 2v sine 2 alpha is equal to minus g cos alpha multiplied by t. Minus goes out with minus, and we will get t is equal to, we can open sine 2 alpha also, so this will be coming as 4v sine alpha cos alpha divided by g cos alpha. Cos alpha cancels out, so we get t is equal to 4v divided by g sine alpha. This is the time. So now we are going to consider equation 1. So from equation 1 we have v cos theta, v cos 2 alpha is equal to v cos theta minus g sine alpha into t. So we are going to substitute the value of t in this equation. So we will get this as v cos 2 alpha is equal to v cos theta minus g sine alpha multiplied by 4v sine alpha divided by g. G cancels out with g, so we are left with v cos 2 alpha is equal to v cos of theta minus 4v sine square alpha. Now we know that cos 2 alpha can be written as 1 minus 2 sine square alpha, which is equal to v cos of theta minus 4v sine square alpha. So bringing this into left side and taking v as common, we will be left with 1 minus 2 sine square alpha plus 4 sine square alpha is equal to v cos of theta. So this will be v. We get this as 1 plus 2 sine square alpha is equal to v cos of theta. Now this can be written as, bringing cos theta to the left side and taking v to the right side, we get 1 plus 2 sine square alpha divided by cos of theta is equal to capital V divided by small v. And in the equation 3, from equation 3 we already have that v sine 2 alpha is equal to v sine theta. So from here we find out capital V divided by small v is equal to sine 2 alpha divided by sine theta. So we put here, so we get this as 1 plus 2 sine square alpha divided by cos of theta is equal to sine 2 alpha divided by sine theta. Now we are going to further simply manipulate the left and right side. So we can write this as sine theta upon cos theta is equal to sine 2 alpha divided by 1 plus 2 sine square alpha. So we can say that tangent of theta is equal to sine 2 alpha. We can write it as 2 sine alpha into cos alpha divided by 1 plus 2 sine square alpha. So in the right side we are going to divide and multiply by cos square alpha. So dividing and multiplying right hand side by cos square alpha. So this will be coming as 2 sine alpha cos alpha divided by cos square alpha divided by 1 plus cos square alpha plus 2 sine square alpha divided by cos square alpha, and this is equal to tangent of theta. So cos square goes by this function, so this will be equal to, we are left with now 2 tangent alpha, and 1 upon cos square is given as secant square theta alpha, secant square alpha plus 2 tangent square alpha, and this is equal to tangent of theta. Now secant square alpha, we can write this as 2 tan alpha. Secant square is 1 plus tangent square, so we write this as 1 plus tan square alpha plus 2 tan square alpha. This is equal to 2 tangent alpha and 1 plus 3 tan square alpha, and this is equal to tangent of theta. Multiplying it to the left side, we get tangent of theta 1 plus 3 tan square alpha is equal to 2 tangent of alpha. This was the first part, so we have proved the first part. So we are further going to continue with the same equation. Let me write it here. We wrote last tan theta is equal to 2 tan alpha divided by 1 plus 3 tangent square alpha. From here we find out cot of theta. Cotangent of theta is equal to 1 plus 3 tan square alpha divided by 2 tan alpha. From here we find out cosecant square theta. Cosecant square theta is equal to 1 plus cotangent square theta. Substituting the value of cot theta as 1 plus this, so we get 1 plus 3 tan square alpha divided by 2 tan alpha and its square. We open the square, we get 1 plus 9 tangent 4 alpha and plus 6 tan square alpha divided by 4 tan square alpha. Taking the LCM, this will be equal to 4 tan square alpha plus 1 plus 9 tangent 4 alpha plus 6 tangent square alpha divided by 4 tan square alpha. 4 tan square alpha plus 6 tangent square alpha will be equal to 10 tangent square alpha. So we can write this as 9 tangent 4 alpha plus 10 tangent square alpha plus 1 divided by 4 tangent square alpha. This is equal to cosecant square theta. This is a quadratic in tangent square, so we can solve this as a quadratic function. We get this as 1 plus tangent square alpha and 1 plus 9 tangent square alpha divided by 4 tangent square alpha, and this is equal to cosecant square theta. Now 1 plus tangent square alpha is nothing but secant square alpha, so we can write this as secant square alpha multiplied by 1 plus 9 tangent square alpha divided by 4 tangent square alpha, so this is equal to cosecant square theta. So taking the square to the other side, we get this as cosecant theta is equal to secant alpha divided by 2 tan alpha and square root of 1 plus 9 tangent square alpha. So from this we are going to find out sine of theta. So we know that sine of theta is equal to 1 upon cosecant of theta, so which means this will be equal to 2 tangent alpha divided by secant alpha square root 1 plus 9 tan square alpha. Now we can write this as tangent alpha as sine alpha upon cos alpha, secant alpha is 1 upon cos alpha, so ultimately this will be solved as sine theta is equal to 2 sine alpha divided by 1 plus 9 tangent square alpha and its square root. But from equation 3 we already know that v sine 2 alpha is equal to v sine of theta. So we are going to put sine of theta here. So we are going to get this as v sine 2 alpha is equal to v 2 sine alpha divided by 1 plus 9 tangent square alpha and its square root. Sine 2 alpha can be written as 2 sine alpha cos alpha. We get this as v 2 sine alpha cos alpha is equal to capital V 2 sine alpha divided by 1 plus 9 tangent square alpha. Sine alpha cancel out with sine alpha, 2 cancel out with 2. So we are left with V is equal to capital V divided by 1 plus 9 tangent square alpha multiplied by cos of alpha. Bringing cos of alpha inside the square root, so we get V is equal to capital V cos square alpha plus tangent square can be written as sine square upon cos square, so it cancels out. So we get 9 sine square alpha. Cos square alpha can be written as 1 minus sine square alpha plus 9 sine square alpha raised power 1 by 2. This is equal to V 1 plus 8 sine square alpha raised power 1 by 2. Or as per the question, we can write this as small v is equal to capital V 1 plus 8 sine square alpha raised power minus 1 by 2. This proves our second part. Thank you.